Hi guys. Okay, so we are actually going to be jumping to section 12.1. We're not doing all of 12.1, but just part of it. This gets us into synthetic division, which is just another method instead of using long division, because long division is kind of messy and tedious, and there has lots of rooms for error. So whenever we teach long division, we also teach synthetic division right with it. You should be able to do both of them. So when we come back after your next rotation, you are going to be taking a Chapter 5 test. So you should be able to do both of them because you'll be required to do both of them. But as we move further into the course, we'll probably just be using synthetic division instead of using long division when we have to divide our polynomials. Okay, so what is synthetic division? Let me move my head out of here. Synthetic division is a shortcut to dividing polynomials, but can only be used when dividing a polynomial by a binomial of the form x minus k. So it needs to be linear and it needs to be a binomial for your divisor. That's the only time that you're going to be able to use synthetic division. You're not going to be able to use it for those really crazy ones where your divisor was, I think we had one that was like 3r squared minus 2. Okay, so this is what it looks like. So we're going to use synthetic division to divide 5x squared plus 16x plus 15 by the divisor of x plus 2. Okay, so notice that my divisor is linear and it's a binomial. So that means I can use synthetic division. So now this is how synthetic division works. So you take your divisor and you have to figure out the zero of that divisor. When I say zero, what number of x would zero out or cancel that positive 2? And that's negative 2. So I'm going to take the zero. So the zero of this would be x equals negative 2. So that would get me 0. Negative 2 plus 2 is 0. So I'm going to take that 0, I'm going to put it in a half box. Okay, so that goes here. Then all I'm going to do is I'm going to focus on my coefficients. So this is why it's much less messy. It's not as messy, I guess is what I should have said, as long division, because all you're going to do is focus on coefficients and not the variables. So I have a coefficient of 5, I have a coefficient of 16, and I have a coefficient of 15. Notice there were no gaps. I have a second degree, 1 degree, 0 degree. So no gaps, don't need a 0 or a space filler. So now I'm going to put a big addition bar right here, and I'm going to do the following move. I'm going to drop down my first coefficient, which is 5. Because if you guys remember back in long division yesterday, every time we were multiplying something that had just x, it was going to be like x. What times x is 5x squared? 5x, right? So we always will bring down that 5. Now this is where all the fun happens. Now what we're going to do is I'm going to take my negative 2 inside that half box and multiply it with 5. Okay, so we're multiplying here. So I'm going to write it out just so you have it for your notes. So we're now going to so this is your first step, move number 1. Move number 2, multiply, and then put that product here. So that's negative 10. This is going to look really crazy, but this is the best way I can see for you guys to put it in your notes so you have it. Then your next move is to add. So step number 3, add. Not like in long division where you subtract here, I'm physically going to add and I get 6. Now I'm going to multiply again. So I'm going to multiply my negative 2 times 6. So negative 2 times 6 and put that product up here. So that adds, so I have space. So negative 2 times 6 is negative 12. Adding that gets us 3. Okay, so let me go through this without all this craziness. You need to go back and get all that down. So I have a negative 2 in my half box. That's where the 0 came from. I have my coefficients of 5, 16, and 15. Our first move is to bring down that 5. Then I'm going to do negative 2 times 5 to get negative 10. Put that underneath my next coefficient. Add straight up and down gets me 6. Negative 2 times 6 is negative 12. Put that underneath your next coefficient. Add straight up and down gets me 3. Now, every time you divide a degree of 2 by a degree of 1, the result would be a degree of 1, right? X squared divided by x would be 1x. So now just fill in. Here I have 5x plus 6. There's my constant. And this right here will always be your remainder, right? So how do we write remainders? 5x plus 6 plus my remainder of 3 over the divisor, which was x plus 2. Pretty cool. A lot less crazy. So if I had a degree of 2 to start out with, then my quotient will be a degree of 1 when I divide it out. If I had a degree of 3, dividing 1 time would get me to a degree of 2. So then I would do x squared plus x plus constant plus remainder. All right, so let's do another one. X squared minus 6x plus 5 divided by x minus 1. Again, we have no missing gaps. My 0 of x minus 1 is a positive 1 because that would get you 0. My coefficients are 1, negative 6, and 5. Bring down your 1. Now we'll do 1 times 1, which is 1. Put that underneath the negative 6. Add straight up and down, gets me negative 5. Then we'll do 1 times negative 5, which is negative 5. Put that underneath my third coefficient, which gets me 0, which is nice because that means I have a remainder of 0. I started with a degree of 2. Taking away 1 gives me a degree of 1. So my answer is right there, x minus 5, with no remainders. A lot more simpler than long division. All right, here's a crazier one. So we have a degree of 5. Notice we don't have a degree of 4. So I'm going to need to put in a space filler. We have a degree of 3, 2, 1, 0. All right, so my divisor is x minus 2. The 0 of that is 2. Put that in your half box. My coefficient of the 5th degree is 1. My quotient, or my coefficient of the 4th degree is 0 because it's not there. My coefficient of my cubic is negative 2, followed by 3, followed by negative 4, followed by negative 2. Make sure you do carry the signs with you. All right, bring down your first is 1. 1 times, or 2 times 1 is 2. Put that underneath the 0. Adding gets us 2. 2 times 2 is 4. Put that underneath the negative 2. Adding gets me 2. 2 times 2 is 4. Put that under the 3. Adding gets you 7. 2 times 7 is 14. Adding gets you 10. 2 times 10 is 20. Adding gets you 18. So right here is your remainder. We started with a 5th degree. Taking 1 away puts me at an x to the 4th, x to the 3rd, x squared, x constant. They're all pluses because I all have positive numbers. So I have x to the 4th plus 2x to the 3rd plus 2x squared plus 7x plus 10 plus my remainder of 18 over the divisor of x minus 2. There's your answer. A lot quicker than it probably would have been to do long division, hopefully. All right, because we're just multiplying and adding, multiplying and adding, multiplying and adding. All right, here's another one with lots of gaps. So we have x to the 4th plus 81 all over x minus 3. So my divisor is x minus 3. The 0 of that is 3. That goes in your half box. My coefficient of the 4th degree is 1. There is no 3rd, so I need a 0. There is no 2nd, so I need a 0. There is no 1, so I need a 0. And my constant is 81. So 4, 3, 2, 1, 0. Make sure you have all those spaces. This is where the mistakes will be made. You won't put the 0 into the gap, and that's going to completely make your answer wrong. So be careful with that. All right, bring down the 1. 3 times 1 is 3. Put that underneath the first 0. Adding gets us 3. 3 times 3 is 9. Put that under the next. Adding gets you 9. 3 times 9 is 27. Adding gets you 27. I'll use my calculator on this. 27 times 3 is 81. Positive 81. So adding gets us 162. We started with a 4th degree. So that makes us start with an x to the third, x squared, x constant, remainder. So x to the third plus 3x squared plus 9x plus 27 plus 162 over x minus 3. Okay, so multiply, add, multiply, add, multiply, add. And then start with one less degree because we're dividing out an x, right? And that x minus 3. So one less degree and then fizzle it down through as your coefficients for all the rest of the other terms. All right, that concludes your notes. Thank you.